So this example is a little bit different in that they don't ask us to find a number, a value for the answer. They want to know if this box is speeding up, slowing down, or moving at constant velocity. So it's 40-degree ramp here. Let's see what kind of forces we're dealing with. We've got, so it says at this instant, it is sliding up the ramp. Okay, so it's moving up. So the velocity is up the ramp, which means the friction is going to resist that. So friction is down the ramp. And it looks like there's a push here. There's a 200 Newton applied force on the box aiming up the ramp in parallel to it. Okay, so basically the question is that push, how does that push compare to the friction and the gravity? Yeah, that's basically the question here. Okay, so I will define my directions here. So X I'll make down the ramp, Y I'll make perpendicular to the ramp. Then I'll get a free body diagram going. So gravity will be down. Draw the components in there. Normal force will balance out the y component of gravity. And then we'll have our friction pointing down the ramp. And we'll have our applied force pointing up the ramp. So they're going to be a little ambiguous in size because the question's asking which one's going to win, basically, or is it going to be a tie? So I'm not sure if I drew the sizes right of the x direction vectors, but we will see. Okay, in terms of equations, the y direction allows me to say that the normal force equals to the y component of gravity, or the normal force equals to mg cosine of theta. Now the x direction, I don't know, basically all I need to do is figure out which side wins. So if I split my work up into the positive x direction versus the negative x direction, and just see which one's bigger, then that'll do it for me. So in the positive direction, positive x direction, which I've defined as sliding down the ramp, we've got friction. And we've also got the x component of gravity. And in the negative x direction, so up the ramp, we've got the applied force. So it's going to calculate each of these and compare. So I'll start with the positive x direction. The formula for friction is mu times normal. And the formula for the x component of gravity is mg sine of theta. And I'll make a little substitution here. I'll call the normal force equation as equation 1. I'll sub it into this expression here. Okay, so that's going to be mu mg cos theta plus mg sine theta. I'll factor out mg. And substitute. Okay, let me type that in. Okay, so I'm getting 113 newtons here. So that's all the forces pointing down the ramp, and the forces pointing up the ramp, the negative x direction, it's just the applied force, and it's just given right to us. It's a lot easier. You just write what it is, 200. So, therefore, since the forces in that one direction is bigger than in the other direction, therefore the box will accelerate that way. I'll say up the ramp. Up the ramp. So the question is it speeding up, slowing down, or moving at a constant velocity? So basically, is the acceleration in the same direction that it's already moving, or in a different direction, the opposite direction? So at the very top here, I drew which way the box is moving. So the box is already moving up the ramp, and it's also going to accelerate up the ramp. Therefore, it's going to actually speed up. So I'll write that a bit more in full. So I'll say this is in the same direction as the velocity, so it will speed up. We could actually figure out the value if we wanted to of the acceleration. We have the information. We can get the net force out of this. And we know the mass too, so we can use Newton's second law if we wanted to get the acceleration. But the question doesn't ask for it, so I think we are done here.